One whole has parts. Equal parts matter. One part is a unit fraction.
Welcome to the river bend. I'm watching Sedge, a young otter who takes his meals right down there on that sun-warmed rock. Every day, Sedge brings round food to this spot, and he has a clear goal. He needs to divide it into fair, identical portions to share with the rest of the river. To do that, he has to follow the standard for all fractions. If every single divided piece isn't exactly the same size, it isn't a fair share. Watch him work. Sedge takes a single round lily pad, presses his paws into the center, and snaps it cleanly into 4 separate identical quadrants. If we slide just one of those pieces aside, we get a fraction called 1/4. The bottom number tells us the whole pad was split into 4 equal parts, and the top number tells us we are holding one of them. Anytime you pull a single piece from a fairly cut whole, its name is always 1 over the total number of pieces. That's how we define a fraction. But what if Sedge wants to give someone a larger portion? He can just gather a few of those exact same pieces back together. He slides them together with his paws. That's 1 piece, 2 pieces, 3 individual 1/4 pieces. Looking at this diagram, gathering 3 pieces makes 3/4. The top number is 3 because Sedge holds 3 pieces, but the bottom number stays at 4 because the original whole was still cut into 4 equal parts. Fractions work just like the whole numbers you already know. You can count them and stack them as long as each piece is the same size. Let's see Sedge divide something for a smaller group. He brings a round berry cake. He splits the cake into 3 equal parts and pulls one section away to show us. One piece pulled from a cake with 3 total cuts gives us a fraction of 1/3. The 3 on the bottom records the total cuts, and the 1 on top counts the piece he's holding. Now he places a clam round on the rock, breaking it into 6 equal, much smaller pieces, and noses one forward. Here is that division in our circle diagram. This piece is called 1/6, following the same rule: 1 piece on top, 6 total equal cuts on the bottom. As the number of cuts goes up, the physical size of each piece gets smaller. You get a smaller share, but the way we name them stays the same. There's one more common share. What if Sedge just wants to split an item equally with a single pup? He takes his food, floats out into the water, and snaps the round directly down the middle, offering one side to the pup. Our diagram shows this is 1/2. It is exactly 1 piece out of 2 total equal parts. When we line up that half next to our 1/3 and 1/4 wedges, you can see it's the largest single share Sedge can give. Even though it's a much bigger piece, 1/2 follows the same naming logic as the smallest sliver Sedge cut today. Look at the rock and all the different shares Sedge created. A unit fraction, like 1/3, is just 1 piece of a whole cut into equal parts. And if you have more than 1, like 3/4, you just count them up. Cut into equal parts. 1 piece is 1 over how many, and count up from there. My time at the river bend is done for today. Equal pieces make fair shares. Before I see you at the next bend, think about this. If Sedge cut a round into 8 equal parts and took 1, what is that piece called? And is it bigger or smaller than 1/4? Once you can name the pieces and count how many you have, you can work with any fraction Sedge brings to the rock.
Name the denominator. Shade 1, equal part. Read the fraction.